Hello nerdy nog dogs, and welcome to your first video study guide for chapter 2 with Nerdy Nog Dog Productions. And I promise you it is pretty nerdy, but I want you to get used to the way in which Math and Focus asks the questions on the test. So the first question asks you to find the sum, and here's an example. Find the sum of 3,521 and 2,239. So in the last go around of tests, I saw that you guys have absolutely no problem in addition and regrouping. So I'm going to do this quickly. And then I get my answer of 5,760. The second part of the question is to round your sum to the nearest 100. Okay, so again, sum meaning the answer of an addition problem. Now we have to round it to the nearest 100. So we've got the ones column, tens column. Here's our hundreds. This is the number in question. So I instantly know that nothing is going to change with my thousands place. That stays the same. We are rounding to the hundreds. This is what's in question. So to round to the hundreds place, I look to the right of the hundreds column, and in there is a digit 6. Now what's in question is this number in the hundreds column going to change? Our rule of thumb is 0 to 4 stays on the floor, which means this 7 would stay the same. 5 to 9 climbs the vine, meaning the 7 goes up one digit. And in this case, 6 falls in, the 5 to 9 climb the vine, pointer up. That means that this is rounding up to 800, and then that zeroes out, okay? So to answer the question appropriately, you would find the sum and then round to the nearest 100. What does this rounding to the nearest 100 mean? Well, you ask, I will tell you. If we were to put this on a number line, and again, this is just another visualization of what it might to try and help catch those of you who still need that aid. If I were to put this on a number line, I know I'm rounding to the hundreds, so let's start there. I'm either going to have 800 or 700, right? In between those two, let's see, would be, 750, okay? Now let's add on our thousands place. We have 5,800, 5,700, and 5,750. So now if I needed to visualize where this is on the number line, well, it started with 5,700, and 60. That means that number would be right here. So visualizing this might make it easier to understand. Is it closer to 5,800 or is it closer to 5,700? And we can clearly see it is on this side of the number line. So that is just one way to represent rounding, okay? So pay attention to whether it asks you to round to the nearest 100, 1,000, sometimes the tens column. Okay, next on the agenda, they ask you which is the closest estimate. Okay, so they might give you something like this, 72 times 25. So a fairly easy multiplication problem. But then they're asking you which is the closest estimate to this. Okay, so then they give you options like 70 times 20, maybe 70 times, let's say 30, and how about 75 times 30? So what are we going to go with? Well, if we had to round this original number, again, whenever it doesn't direct you where to round to, we are rounding to the largest place value, okay? So that would mean I'm looking at the tens column in which to round. right? 0 to 4 stay on the floor, which means this number stays the same. We would end up with 70. And I look to the ones column to change my tens column, or round to the tens column. And therefore 5 to 9, climb the vine, whoop, this digit is going up. So our final answer or estimate of that multiplication problem would be, or the closest would be 70 times 30. And if that were an option, that is obviously what you would choose. Hope that makes sense. Moving on. It then asks you about what is an estimated quotient, and it gives you an option. So let's just say I had 252 divided by 6. I know that quotient means, and again, we have tools in the classroom. Take a look around the classroom if you don't recognize a vocabulary word. Quotient is the answer to a division problem, right? So if I had to estimate this quotient, could I do long division? Sure, and then I could estimate or round the answer at the end. But another option is to just think of compatible numbers and our divisibility rules. So if the number is divisible by both 2 and 3, now I instantly know it's divisible by 2, right? This isn't 252 is an even number. And if I'm following my divisibility rules, it is divisible by 2. Now, to find out if it's divisible by 3, if the sum of the digits of the number are divisible by 3, it is divisible by 3. So let's see. Sum, meaning adding. 2 plus 5 gives me 7. Plus 2 more gives me 9. 9 is divisible by 3. Therefore, this follows the divisibility rules, meaning 252 is divisible by 6. Okay, so we know that we can go ahead and move along with this division problem. And if I were to do that, 6 goes into 2 0 times. 6 goes into 25. We'll go in 4 times, end up with 24. Now we get to long division next chapter. Most of you have been exposed to it. So another thing that you could do would just be to estimate and look at compatible numbers, right? So let's get to that in just a sec. So 42 would be my answer. If I were to round 42 to the nearest 10, I look at the 2. The 2 is 0 to 4, stay on the floor, meaning the 4 does not change. And if I were to estimate my quotient, I could estimate that or round it to 40. Now, another thing to think of is compatible numbers, okay? So we can think, well, rather than doing 252 divided by 6, I can kind of think, to give me a jumping off point or a jumping off spot, change that to 250, and I know 250 is divisible by 5 because it ends in a 0, right? Again, following my divisibility rules. So I could pretty easily do that division, right? 5 goes into 25. Well, I know that's going to go in 5 times. With 0 left over, bring down the 0, which means that I'm going to have a 0 there. So instantly, I see that that is divisible by 5 50 times. Then I can reverse that, right? My inverse operations, because they are related. Remember this symbol? They are related. Brother and sister, that weird cousin. So I could do 5 times 50 and get 250. So I look at different ways in which I can find compatibility with these numbers if they're not making sense. And we do get to long division next chapter, but it shows up on this test. And just to estimate, they want you to get comfortable with the numbers. Another thing that is asked is, what is the sum of the first 2 multiples? So say I had the digit 4. Okay, what is the sum of the first 2 multiples? Well, we might need to look at the first multiples of this number. So I know that I've got 4. I know that the second, so this would be the first multiple. Second multiple is 8. Third multiple is 12, right? And that would keep going. Fourth multiple is 16. Okay, so then it says, what is the sum of the first two? Sum, meaning adding, means I'm going to take these first two digits and add them together. 8 plus 4 is 12. Well, the sum of the first two multiples of 4 is 12. Okay. Let's see. I want to get the exact verbiage so you guys are comfortable with this. And again, you won't get this much detail as we move forward through the testing, but once you're comfortable with the math and focus lingo. It does ask you to find the product. What does product mean? Look at my clue boards, look at the tools in the classroom. So one example might be 214, product meaning multiplied, times 7. Well, I end up, okay, 1,498. But then it asks you to estimate to check that your answer is reasonable. Well, I could estimate by rounding this answer, right? That's one form of estimation. Or maybe rounding before I multiply. That would give me easy digits to work with. So 214, if I'm rounding to the nearest hundred, again, if it doesn't tell you where to round, you round to the largest place value, okay? So I'm rounding to the hundreds column, meaning I'm going to look at the tens column to determine what to do. 0 to 4, stay on the floor. This 2 doesn't change. Everything else zeroes out. Times 7, I can keep it times 7. That's easy, right? I know that this ends up being 1,400. Is that close to 1,498? It's within reason, right? I mean, that's still almost 100 greater, but it's within reason. That is a reasonable estimation. And that's what they're looking for, okay? Greatest common factor. So if I were to ask you for the greatest common factor between 8 and 12, I would need to find all the factors for those numbers. And first I would say, well, I know one factor, yes, I use nerdy voices on this, is always that number times itself, right? Okay, other factors for 8 would be 2 times 4. Other factors for 12 would be 2 times 6, 3 times 4. And so now we have to look at what is their greatest common factor, meaning what is the largest digit they have in common. And in this case, this side has 4, that side has 4. There is nothing larger. They both have 1, they both have 2, but 4 is the greatest common, meaning the same factor. Okay, one other thing I want to show you, because it does ask for, is lowest common multiple. If you remember us doing this in class. Multiples are our skip counting, right? So if I gave you the example of 12 and 15, if I were to look for multiples, the first one being 15, the next multiple would be 30. After that, 45. For 12, first multiple is 12. Then after that would be 24. And my brain's not